Okay, so in this lesson we're going to talk about polarity. Polarity is the unequal sharing of electrons in an atom or molecule, or the temporary unequal sharing due to the movement of electrons. So what is molecular polarity? So that's what we're going to first. Molecular polarity is defined as the polarity within and between molecules. And we call these intermolecular forces when it's between molecules. While if it's in the molecule, it's intramolecular forces if it's within molecule. And there's two types that we talked about previously. Okay, it's basically London forces versus what we're going to call now dipole forces. Okay, now we know London forces are temporary attraction between temporary dipoles, but dipole just means that when two molecules have a dipole, what will happen? What we gotta note here is that this is between covalent compounds. So what are London forces? Well, London forces are temporary dipoles. And it's from basically the movement around the movement of electrons around an atom. So you might remember if I draw a hydrogen atom and I draw another hydrogen atom, when the electron is over here, what's going to happen is it's going to cause this side of the atom to be more negative, which means it causes the other side to be more positive. And thus we're going to have a attraction right here between. But because that electron's always moving, what we're going to get is that it's temporary. Okay? So this is a weak force. Okay, what is the dipole-dipole force then? Dipole-dipole forces are between two molecules, with, not temporary anymore, with permanent dipoles. It's due to the fact that, due to difference in electronegativity, which means that it's between the word what we call polar compounds. So here's the thing though. If a molecule has no dipole, it is only London force. So this is the diagram we looked at before, showing the different type of electron clouds. So you can have nonpolar covalent. In this case, these molecules will only have, in a sense, London forces. These molecules will form dipoles, and these ones are the full transfer electrons. So how does electronegativity affect polarity then? So polar molecules equals a difference in electronegativity. But there's another thing. Must also be what we call asymmetrical. I want you to think about it as like a tug of war between atoms. So what does that mean? If an atom has high electronegativity, it pulls the electrons towards it. And this leads to a polar molecule. Only if it is asymmetrical. So I'll explain to you with a few pictures. So here's an example. So here's the first one, H and Cl. Chlorine is much more polar. In this case, because it's much more electronegative, because that it is polar. This is higher En. So thus it pulls electron cloud towards it. So if what you're going to see is if there was electron cloud around this, the electron cloud will look something like this. For example, it will have a much more larger electron cloud around it. This one right here is also polar because in this case this is a trigonal bipyramidal, and because that it's going to pull electrons upwards, and thus because pulling upwards it's asymmetrical. So it's also polar. Okay, what about this one? Now because this one, if you think about it, this fluorine is pulling electrons this way, this is pulling this way, and this fluorine is pulling electrons this way. But because they're pulling equally, it's symmetrical. This is nonpolar because no one's going to win the tug of war. Imagine if you were all pulling a rope, one going this way, one going this way, one going this way. This boron will never move. So you can think of it as almost like moving. Well, this one, if you look at it, if this hydrogen pulls this way, this hydrogen pulls this way, this hydrogen pulls this way, it's going to pull the whole molecule towards one side. Same with this one. If these two are pulling, chlorine will win the tug of war. In this one's tetrahedral again. Because tetrahedral is a symmetrical shape, if this chlorine pulls here, this chlorine pulls into the page, this other chlorine pulls into the page, this chlorine comes out of the page, this carbon in the middle will not move. So it's symmetrical. So in this case, this one is symmetrical. Just like this one. This one's also symmetrical. This one, on the other hand, yes, this hydrogen here are all symmetrical, but this chlorine causes the tug of war to become this way. Because of that, this is asymmetrical. Just due to that chlorine sitting there. If this was hydrogen, for example, if this chlorine was a hydrogen, then this is symmetrical and then it will be nonpolar. But because of this chlorine, this becomes asymmetrical. So the tug of war gets pulled this way and this carbon will move. So that's why this one is polar. So how does dipole-dipole compare to ionic? Well, the key thing here, what we do know is that ionic is a full transfer of electrons. Well, dipole-dipole is a sharing of electrons still, because your ionic is ionic, while dipole is covalent. Okay. But because of this, what's going to happen is there's a difference in strength. If you're talking about strength of bond, ionic is the strongest. Then it goes polar, and then it goes nonpolar. Okay, that leads to how we have different strengths of bond. Because ionic is a full transfer of electrons, there's a strong electrostatic attraction. As always, make sure you keep yourself safe and healthy, and I'll see you soon.